Hi folks, welcome back to MacroLearning. So we are in the organic chemistry part here, still with alkanes, and this question is still about halogenation of alkanes. So it says, draw the structures of all possible monobromination products of butane and monobromination products of 2-methylbutane, and estimate the percentage of each product for each case, based on the relative reactivities. Primary hydrogen to secondary to tertiary hydrogen being 1 to 220 to 19,000. Excuse me. So to get the product ratio, we have to not only use the reactivity ratio that's presented here, but we also have to take into account the number of each type of hydrogen. How many primary hydrogen, how many secondary hydrogens are there? So anyway, the structure of butane is here. And the monobromination products, I think one of them would be this. Another one would be this. Okay, and those would be the only possible products for butane's monobromination. Okay, because if the bromine ends up in this, on this carbon or this carbon, it will be still the same structure as either one of these. So these two are the only possibilities. And let's see, this product is from the reaction of bromine with the primary hydrogens, right? Whereas this product is from the reaction of secondary hydrogens with bromine. Right? Well, they're pointing to the product. They're not necessarily pointing to any specific carbon atom or anything, but you get the idea. So the product ratio would be, let's see, what we have is the relative reactivity of primary hydrogen to secondary hydrogen equaling 1 to 220, right? So to get the product ratio, we have to do this. Well, let's call excuse me, let's call this product 1 and this product 2. So the ratio of 1 over 2 would be the reactivity ratio of the corresponding hydrogens, primary over secondary. That's not all. We have to take into account the numbers of hydrogens, so that times the ratio of how many primary hydrogens over the number of secondary hydrogens. Okay, so now this is of course 1 over 220 times, what is this then? This number of hydrogens for primary hydrogen is 6, right? And for secondary hydrogen, the number of hydrogens is 4. So the overall result or answer is 6/880. So that's the ratio of 1/2. So when it comes to percentage, we need some further simple calculation. That is percentage of 1 equaling 6/880 plus 6. Alright, well, times 100. Let's omit that one real quick. Let me pull out my calculator. Okay, 6/886. So it's 0.68. Oops. Okay. 68. If we want two significant figures, that is percent, and the percentage of number 2 would be 880 over 880 plus 6, being 80 over 886, 99.32%. Okay, well, the other way to get this is simply take this and subtract it from 1 or 100%, and you get the same number. Okay, so that is it for butane. Now the second part. Okay, now on to the second part with 2-methylbutane this time. So what will be its monobromination products, and what will be the ratio of the products to each other? So 2-methylbutane is, let's see, 2-methyl, so a methyl on the second carbon, butane. Okay, so monobromination products, let's see. Let's use the simplified structure. That's 2-methylbutane, and bromine could end up in here. Okay, or it could end up on this carbon here, on this side. So these two, oh, there's another one actually. No, that's it. No, sorry, never mind. Never mind. Because this one will be the product of primary hydrogens reacting with bromine, right? Will be the product of these hydrogens only. These 6 hydrogens reacting with bromine would all lead to this product here, whereas this product is the result of these primary hydrogens. Let's use the same color here actually. These hydrogens reacting with bromine will give this product. Okay, and let's call this one number 1, this one number 2. Okay, and what are the other possible products? It could be this, where bromine is attached to this carbon here. So this would be the result of bromine reacting with these hydrogens, right? With these secondary hydrogens. So this will be number 3. And then another possibility would be bromine reacting with the tertiary hydrogen, and that will be this hydrogen reacting with bromine, giving this product. So we'll call this number 4. So these are all the possible monobromination products. That's it. And to calculate their percentages of these products, we'll take into account the relative reactivities of all the different hydrogens, and we'll need to take into account the numbers, how many of each different hydrogen are there, right? So let's see, say number 1, the ratio of number 1 to 2, let's do it this way, to 3 to 4 would be the relative reactivity of each one times the number of hydrogens for each one compared to each other. I'll show you. So for number 1, the reactivity would be primary hydrogen is 1, right? So well, let's use the symbols first. So for primary hydrogen, you know what, let's call these 6 hydrogens primary hydrogen A, and these 3 we call it primary hydrogen B, because all these 9 hydrogens don't lead to a single product, they actually lead to 2 different products. These 6 corresponding to this product, or these 3, these are the 3 leading to this product instead. So we have to distinguish between these 6 and these 3. So the A-type primary hydrogen's reactivity times the number of A-type primary hydrogen, and let's see, number 2 will be this other type of primary hydrogen. So primary hydrogen B times number of primary hydrogen B atoms, and then the third one is from the secondary hydrogen. So that of secondary hydrogen times number of secondary hydrogen, and there's another one, number 4, from the tertiary hydrogen. So reactivity of that guy times number of the hydrogen, which is only 1, of course. Excuse me. Okay, so let's put in the numbers now. So the first part will be, what is the reactivity, relative reactivity for these hydrogens? It's 1 times number of these hydrogens. It's 3 plus 3 being 6, right? To the B-type primary hydrogen's reactivity. What is it? It's still 1 also, right? They lead to different products, but reactivity-wise, they're defined as, well, they were found to be the same as each other. So this one also being 1, and number of this type of hydrogen is 3. And the third part, secondary hydrogen, this one in yellow, the reactivity, relative reactivity is going to be 220, as given in the question, times number of secondary hydrogen, which is 2 of them, right? And the final part, tertiary hydrogen's relative reactivity is this big guy here, 19,000 times the number of tertiary hydrogen, only 1 of them, only 1, so that being 6, 3 to 440 to 19,000. So that's the ratio, the relative ratio among all the 4 products from 1 to number 4. That is it. Now to calculate the percentage, it's pretty straightforward. I can leave it to you guys actually. But what you do is for number 1, let's say you just take the number for number 1, which is 6, and divide it by the sum of the 4 numbers. That way you get the percentage for number 1, which is low because of the low reactivity of the primary hydrogens, despite the number of hydrogens being higher because the reactivity is so much lower. The number, even if you multiply it with the higher hydrogen number, it still doesn't help increasing the product percentage very much. So that's why it's got such low ratios or product percentage. But that's pretty much how you got the ratios between the products and how you will be calculating the percentages for each product. So I hope that makes sense to you. And again, any questions you have, any comments or thoughts you have, please do not hesitate to let me know by calling or emailing. And please subscribe to my channel and or visit my website at MacroLearning.com. Okay, thank you so much. See you next time.